to Complexity Made Simple. My name is Paul Allen, and the subject of today's video newsletter, well, we're going to talk about doing analysis, and we're going to talk about keeping your analysis simple. Okay, this is a response to keep your analysis simple. This is a response to a client of mine who sent me an email, and he's asking me a question about analysing some data, and he wants to do a goodness of fit test and a chi-squared test, and he wants to know what test to do and whether it will work and all sorts of things. And all he's basically trying to do is to say, is my supplier sending in good quality parts? Is my supplier's process in good shape? And should I go and visit them? And he's got way too complicated in his analysis. And this is one of the problems with Six Sigma. We've got this process: define, measure, analyze, improve, and control. And effectively, there are two types of analysis you can do. Your process is in one of two states. You are either in a state of chaos, or you are in a state of control. Now, when your process is in chaos, when we're looking for chaos over here, chaotic analysis can be kept very simple. We don't need chi-squared, goodness of fit, hypothesis tests, all of this kind of fancy Dan mathematics. Six Sigma gets itself into trouble when it starts doing this. When we are in control, however, and you are trying to take the process to excellence, you're trying to go to excellence, then what you're doing is you're doing experiments. You're often doing designed experiments. At that point, what would I expect you to do? Then I would expect you to get very fancy and complex, get the statistical tools out the box, do t-tests. Okay, so this is normally the step most people should be doing. They've got a chaotic process. They know the process is under control. When you've got the process under control, then you can do a t-test. Let's take a look at the email that Anton has sent me, and then let's take a look at the advice I gave him. So, first of all, let's take a look at the email and the question that he asked and the data that he sent along with it. Let's take a look. So here's Anton's email, and it says, I would like to know if the rejection rate month to month in 2017 and 2018 have the same pattern. The rejection rate percent in 2018 could be higher than 2017, but do these have the same pattern of rejection rate? I'm using the chi-squared for goodness of fit to get a hypothesis whether or not the inspection behavior of the supplier are different. My reason for doing this is to find out which months I need to go down to the factory and do random process control and inspection. Just in case you have any experience in this case, please do share if chi-squared, goodness of fit, etc. is the right tool, or is there another tool more appropriate for this needs? I have attached the reject rate for the one supplier I have. Many thanks. So look, let's take a look at the data. So here's the data that he sent me, look. And he sent it to me in years, 2016, 2017, 2018. And then he's worked out an average for each year. Now you can see that what I've very quickly done in the yellow fields, I very quickly put the data into one long string, because the process doesn't know the date, by the way. So I've put the data into one long string in the yellow fields, and then next to it you can see a graph of the 3 years worth of data. Alright, so simple. I've just put it in a run chart. Okay, now that's it. That's all we need to do. Now what am I looking at? Well, I'm looking at whether the process is chaotic or not. If you look at that graph, it's like this. It's all over the place. And he's asking the question, do I need to go and visit this supplier? Yes, of course you do. They are sending you chaotic results. There is no sign that the process is under control. If you look at the graph, yes, there's periods of control, but then there's wild swings on the graph. You need to go down there and you need to do a process audit. And by the way, these results are his incoming results. The likelihood is that if these are the results that he's seeing inside the factory, it's an awful lot worse than this. Yeah, much more chaotic. And you're only seeing the filtered data that they're sending you. So look, keep it simple. Why would you want to do a goodness of fit? Why do we want to bother waiting a year? So think about what he's doing. He's saying, I waited until the end of 3 years before I looked at a simple graph, and then I started asking the question, do I need to visit this supplier? But let's go back to the graph. Look at the graph. Look how chaotic it is. Right from the early performance, 4, 5 and 6 really wild. Then the process calms down. Then by data point 14, it goes really wild again. And then by data point 30, it goes really wild again. You'd want to visit these people straight after those individual data points. Now, of course, he could turn this into a control chart. So he could have simply put a control chart there. And of course, that would be telling him, maybe there's something wrong, go and visit them. That would be the next logical step. But the first logical step is keep it simple, use a graph. And I find too many people, they won't use the simplest tool, use a run chart, use a graph, maybe turn it into an SPC chart later if you really want to, but it's not necessary. And they want to start doing t-tests and hypothesis tests and goodness of fit tests and the Anderson-Darling test for normality. All of that is nonsense and not needed. Get your process under control, keep your analysis simple and visual, and you will find 90% of the time that's all the analysis you'll need to do. Only when you start doing DOEs do you want to get t-tests and hypothesis tests out the box, but that's when we're doing something very clever and we really want to learn how our process is working. We want to be cheaper, faster, better than everybody. Then we need heavy duty statistics. But without that, getting your process out of chaos, keep your analysis simple.